4 examples on slope of a tangent. It's like this is important or something. The previous example I did using a lot of references to the grid, or sorry, to the graph, but in this one, I'll just follow the formula because you should be able to do them either way. So the general formula for finding the slope of a tangent is you use the limit as h goes to 0 of f of x plus h minus f of x all over x plus h minus x. So, limit as h goes to 0. How do we fill in all this stuff? First, here's our function, and we have to put x plus h into it. Now, you can put in 3 plus h if you want to commit to using this point, or you can just stick with writing x plus h and say, I'll put in the x later. I'm going to do the x version this time just to show you that it works the same. So everywhere that there's an x in this expression, I'm going to put x plus h instead. So here's some big square brackets for this to live in. We're going to have x plus h minus 5 over, and down here where they say x, I'm saying x plus h. That x is going to be 3, they've said so, but I'm going to put off plugging that in until the end just because it's nice to be able to do these things various ways. Minus f of x is just this function exactly as written. X minus 5 over x. If you don't like this way, and if you're writing 3 minus 5 over 3 right now, that's fine. We're going to end up in the same place when we're done. And for you, this would read 3 plus h minus 5 over 3 plus h. All good. Now, in the denominator, x minus x, these are going to cancel no matter what x is. And so the only survivor in our denominator is going to be h. We'll take advantage of that. Writing less stuff is good. And now, how do we clean this up? This is kind of a rough-looking limit, and we can see it's got a division by 0 in it. No roots, so the conjugate thing is not an option. Factoring, not going to happen. But, as we've seen in a few other examples, we have fraction minus fraction here, and so common denominator is an attractive option. I'm going to space this out a bit so we have room to write in some extra pieces. The common denominator for these would be x and x plus h. So let's make that happen. This first fraction needs x's. So there's an x and there's an x. This second fraction needs x plus h's. So there's x plus h. And here is x plus h. Good. Now I get to expand all this, which is not so good. For this first piece, the x multiplies through, and so we're going to get x times x. Sorry, I'll put limit x times x, x times h, x times minus 5. Now we get minus, let's see, x times x. I have to FOIL here, so x times h with a negative on it. Negative 5 times x with another negative on it, that's plus 5x. And negative 5 times h is minus 5h, then another negative on it, so plus 5h. And all that is over, oh, sorry, that was a little premature. The denominator for both of these is x plus h. So everything I just wrote is over x plus h, and all that is our numerator, and it's all over h. Don't worry, that was most of the work. Now when we clean this up, let's see what happens. X squared minus x squared. Those cancel out. Lovely. We have plus xh minus xh. Those drop out also. We have minus 5x plus 5x. This is wonderful. in the end, we have the limit as h goes to 0 of 5h over x plus h. And it's also divided by h. And again, I'm going to write that times 1 over h because I need to conserve space. The h's cancel. Good. Bye. And we're left with 5 over x plus h. And lest we forget, this is in the limit as h goes to 0. Okay, so this form with x's in it is a little more work. The good news is if you decide that x is going to be 3 or 4 or 5 or something, you have that option. You can plug in whatever x you wish. In this case, they've told us do it when x is 3, so now it's time to put in the 3's. I'm putting in 3 for x, and for h, because of the limit, I'm putting in 0. We can do both of those things at once. And we get 5 over 3 times 3 plus 0, which comes out to 5/9. Whew. So this function at that point has a slope of 5/9.